Okay, continuing on, let's talk about, so once we have a mission statement and we've clarified our purpose of what we're trying to do, where do we go from there, right? So how do we translate that into actual system development and stuff like that? Well, once we have our mission statement, then we can come up with what we can call mission objectives. So particular tasks that we want to do to support the goal of the mission. Now, and one of the things also that I want to point out about the mission statement too is, unlike what we might think about in terms of like military missions and stuff like that, a lot of times those those types of missions have a stated end. Like, you know, for example, if you had a mission to capture a certain bad person, a war criminal or something like that, and you had a covert mission to go and use the military to go and take that person and capture them, or an operation that would involve the destruction of some resource that the enemy was using. You know, like in like a lot of spy movies, like Mission Impossible, Born Identity type movies and stuff. There's a stated kind of, we know when the mission is done, right? We know when we've done what we set out to do. A lot of these other ones that we've talked about so far in terms of these companies, there isn't a stated end goal, right? There isn't a final thing. We know when the mission is done because it's just an ongoing thing, okay? And that's okay, right? But once we identify what it is that our organization, our group is trying to do, we need to figure out how we're going to accomplish it. What objectives will we do, okay? So for a mission that may include a database as part of it, we need to start planning out how we're going to do that. Okay, how are we going to collect the data, right? What necessary documentation will we do? How will we design it and how we implement it, right? And that implementation could include even like, what database management system are we going to use, right? Are we going to use MySQL because it's free and it's easy? Not a whole lot of learning. What's the word? Where you have a slope learning. Cannot remember the name of that thing. Learning curve, right? That doesn't have a steep learning curve, right? We're going to use something that's more robust and has a lot more features to it and a lot more, but it may cost something like an Oracle or something, right? One of the things that we need to do is we need to describe the scope and the boundaries. So we need to know where does our system end, right? Because our job is may not be to define everything for all. Let's take an example. Library management system, right? A book, you know, kind of like, well, the homework assignment has library type stuff in there, right? And you're not necessarily going to want to define things like all information about the publishing company and who works for the publishing company and stuff like that, right? Because that's not part of your system. That's outside of your system boundary. Now, you will want to know things like what's the name of the publishing company, because you might need that as part of something that you're storing, right? But you may not necessarily need to know what the publishing company's main phone number is, or who the CEO of the publishing company is, because that's outside of the boundaries of your system, right? So we can also define user job roles, right? As well. So we're going to kind of define what types of things that we're going to be looking for when we get this database system up and running. Let's see. And by identifying job roles, we can also understand how the different views of the system might somewhat overlap, might not overlap at all. So if we look at, this is our entire database that we're going to be trying to design. The database portion of the database system. Now notice, according to this diagram, the database system has a database in it. The database is not the system itself. The system includes other things like the user interface and other things like that, right? But the database itself, we might define what parts of it are different users going to be expected to have access to. We want to collect and analyze requirements, right? So we're going to look at the organization as it exists, right? That we're trying to develop a database system for. We want to, and this is going to work differently based on, okay, are we using a, are we updating something that already exists, or are we creating something that doesn't exist already, right? Because those would be two different ways of, those are two different ways that we may be designing this database, right? Purposes. Okay. There's going to be a couple of approaches. Now, centralized view integration, you're going to see these as very similar to a top-down or bottom-up approach, right? A combination of both is also a possibility. But if you guys remember, we talked about in 101 or 102, I think it was maybe 102, the concept of a top-down approach and a bottom-up, right? Those are two different ways that we might approach designing an object-oriented system. So the main approaches that we'll talk about here that we'll have slides on are centralized and view integration. So a centralized approach is saying, okay, what we're going to do is we're going to try to get the requirements for each different part of the system, each different user view. Then we're going to merge all the requirements into a single set of requirements, and then we're going to use that overall set of requirements, overall set of requirements to design the entire system. Okay. So you might have, this is our user views. Each of them comes with their own set of requirements, right? We're going to combine those requirements into an overall set of requirements for all users. We will talk about later what an ER model is. You'll know what that is in a couple weeks, right? We'll talk about different relations and data dictionary and other supporting documentation that will come out of that. And then that will result in our database system as a whole. Okay, so the idea is we designed the entire system based upon an overall set of requirements that was a combination of all the individual requirements for our different user views. Okay, view integration is more so this would be what is it? Not a forest of trees. It's like kind of building a forest all at once. What is it? Forest of trees. Forest of forests. That's one of those I can't remember. I'm getting old. All right. View integration approach is kind of saying, okay, we're going to create based upon each user view, the set of requirements. We're going to kind of create some smaller databases, and then we're going to put them together into one overall database. Okay. So, like this, right? We have each individual user here that comes with their own set of requirements. We basically create a small database that satisfies this particular set of requirements. Right, and then we merge all of these into one overall database. Okay. Now, we will talk more once we talk about the logical database design phase, about how sometimes these mergings may end up, there'll be some tasks involved with merging here that will be important. Okay. But for now, notice that we build small databases that we can put together until an overall. Which one of these is better? Which one is better? Which one do you think is better? Plus view integration. Okay, I'm going to turn off the camera because sometimes that helps. All right, so the question I asked was, which one of these is better, the view integration approach or the centralized approach? There you go. Somebody was quick on the draw there. Quick. It depends. Yes. Right. And it could depend on something like, okay, how many user views are we talking about? If we're only talking about a couple of user views, well, it might make sense to, instead of having to divide it, because dividing all this stuff up into its own separate tasks is going to have something of what we call overhead. There will be time spent to dividing these things up, right? Building individual databases for these tasks could also provide its own overhead, its own cost as well, right? So this is a substantially complex system. You might want to go with something like this, where each part is designed on its own and has its own team involved, maybe even, and then we put it all together. The centralized approach you might want to do for something that's less individual parts are complex and maybe can be done all together using an overall set of requirements. Right? But yes, it absolutely depends on the situation. All right. Let's see. So one of the things that we will talk about in a future week is about ER modeling, so building a data model. All right, as part of that, it's going to answer questions about how entities, relationships, and attributes of the model exist. All right. We will talk more, like I said, about that when that time comes. All right. We will talk more in detail about conceptual and logical and physical design. Right. So conceptual is kind of, we're going to build a model of the data, all right, based upon the user's requirements, all right. So then the conceptual model, the output of that, usually an ER model, will be the input to the logical design phase. Okay, so when we talk about conceptual, logical, physical, the output of each phase, so the ER model coming out of the conceptual database design is going to be the input to the logical database design. The output from the logical database design is going to be the input to the physical database design. Okay. So what we're going to do is we're going to take a model of the data from the ER model, right? But at the end of the logical database design, we are still not dependent on a particular database management system, right? The output of the logical database design is, we'll call that the logical data model. The next phase, the physical design, is where we start talking about DBMSs. Okay, which database management system are we going to use? Now, let me back up a moment and tell you that just because the physical database design is where we would now need to start talking about which DBMS to use. Sadly, sometimes sadly, does not mean that that's where that decision is made. Sometimes the decision for a DBMS is made much earlier. It could be based upon licensing. It could be based upon what a company may have already decided. It may be based upon what some of our other projects are using, and so therefore we have access and experience using before, which means that sometimes those things we may want to have. We have to decide which things are necessary and which things are nice to have. So, for example, domains, right? So, MySQL does not support domain constraints, right? So if you need that for some reason, if that is a necessity, if that is a requirement, then you won't be able to use that. But what do you do if you really, really need it? You really, really would like to have it, but the company's already decided this is what we're going with. We're going with MySQL. Well, you've got to either figure out other ways to make that happen, or try to convince the company of why their chosen DBMS isn't going to work. All right. Physical is where we actually start talking about things like base relations and file organizations and indexes, indexes, and other types of constraints and security. It's going to be talking about a specific DBMS, right? So this is the final phase of our design phases. Okay, so all right, including physical storage. We start talking about servers. You know, I don't know much about cloud stuff, but I do. But I know that back a long time ago, when I started working for companies, what we would often have is you'd have a single server, you'd have multiple servers, but you have a server that was dedicated to different parts of the system. So we had the first company I worked for, it was a web-based ASP.NET application that had an Oracle database. So we had a database server, we had an application server, and we had a web server. So there were 3 different servers that none of those were the same. So we didn't put that on the same one. All right, and so each of them had its own job of what it was intended to do. All right, but that's when we start talking about the physical stuff. Is where we start talking about, okay, what size server do we need? How much space do we need? And not just for the database itself, but also for the database management system. All right, and so all of that's going to have to be a factor in what we do. So when we go to evaluate and select a DBMS, right, so we want to think about different features, about what some of the things that they'll have access to, and we will talk about here how we might evaluate it. All right, so rating, we say, you know, it's kind of the idea. This is not the way, this is not the only way that we could do this, but basically what this reflects is, you know, what is it? Is it a high value here says that it gives us a good set of choice, right? A good, what's the word I'm looking for? Basically, it is a better option for this particular feature. All right, that's its rating. Weighting would be like, how important is that to us, right? So a low value here would say, okay, if they have this, great, but it's really, really not all that necessary, right? A high value here would say, okay, no, we really need to have this has a good value, all right? Now that doesn't mean that because this high weighting has a lower rating, doesn't mean that doesn't mean we just say, oh, that's not an option, right? Because we do need to count these other factors involved. We end up getting an overall score, and we say, okay, what's we need to get an overall score and determine what which one has the highest score overall of the different DBMSs that we're looking at. All right. Again, what I said was this: the focus of this course is not the user interface, is not the application, but we do want to consider that our database needs to be interacted with by our users. Okay. So again, one of the things I said before about your group project is a simple understanding of this can be shown. Some groups in the past have gotten fine grades and done well with their project with basically kind of a mock-up. You know, I mean, you could create. I wouldn't suggest you use Microsoft Paint, but you could, right? You could do some mock-ups using Microsoft Paint if you wanted to, and show some examples of how your user interface windows would look there, right? But basically, one of the things that we're noticing here is about the parallel activities. We do these things side by side, right? And so as we are designing the database, we design the application at the same time. All right, so we kind of make them work together. All right. And we did already talked about transactions from a database management system, from a database perspective. All right, but an action is carried out by a single user or application and gets access to the information or changes the content in the database. All right. What data is it going to use? What, how, and it's how the user interacts with the database. Or it doesn't have to be a human user, right? It could be a digital user and some type of other system that may use our database. All right. Okay. Another aspect of this, and this is prototyping, is what's the word? Prototyping is part of the what's the word? What am I thinking of? Software engineering. All right, it's a software engineering term, more that is about building a smaller version of the system so that we don't have to build the whole thing. Okay, so kind of let me show you something here. Let me show you. Here. Okay. This is what I was trying to get working yesterday. All right, so let's imagine. All right, so let's imagine that we have an entire system, right? Okay, and there's different components in this system. Okay. So maybe let's think outside the database. So let's say that the database is part of it. The user interface is part of it. Web hosting is part of it. Maybe we even have like a column for security as part of it. Okay. Now there's a couple of different ways we can talk about prototyping. Okay. One, and the whole point of prototyping is to show the customer that we have done some work to the system and that to give them confidence that to give them confidence that we will be able to complete the system. Okay, so one way that we can do that is by saying, let's take some, and actually let me do this. Let me go back. Let's say each of these has its own like separate component as well, right? So, so maybe like if we were talking about like OBS, right? Maybe we talk about OBS, we could have the professor view, the student view. Who else gets views of this stuff? The admin view, like the rector and stuff. The somebody else view, I can't think of anybody else. Guest view. I know we don't have a guest, but you know, okay. But these are just some options, okay? Now, what we might do is we might say, you know what? We are going to create this whole thing. We're gonna do everything for the professor's view of the system, right? We're not going to do anything related to students, anything related to admin, none of that, right? But we are going to design the database for professors. We're going to design the user interface for professors. We're going to design the web hosting and the security aspects for the professors, right? And we're going to show them that. We haven't done anything of the other stuff. All right, we haven't done students or admin or anything like that. But we're showing our customer, our user, we're going to design this fairly well so that they can see that we they can see that we have done that well, and they may fund the rest of the project so that we can do the others. Okay. Another way that we could do that is say, so this we might call this the shallow prototyping, right? Where we take one aspect of the system and we design all of it, right? We design everything, right? Okay. All right. Oh, sorry, one user view and we design all of it. Okay. Another way we might do this is we might say, okay, we're going to design everything of one part of it, like the whole database. Okay, we're going to design and run. I wouldn't suggest this be your prototype, but you know, whatever. Right. So we're going to do the whole database, but we're not going to deal with user interface. We're not going to deal with web or security. So there's no security. We're not talking about that. We're not doing user interface or anything like that. But we are going to design out the database portion for all of these. And when I say this, this is not really how you would do this, because the whole database would be much more than just a prototype, right? But the point is that we're taking some time to design some part of the system to work it out so that when we show that to our customer, they'll say, you know what, we have confidence that you will finish this project. Okay. So you design part of it, some part of it, so that again, the customer will have confidence and fund the remainder of the project for you there. Okay. All right. Let's go back to our slides here. If this lets me do this. Okay. All right. So then when we go to implement, we are going to use our data definition language to actually create the database schemas and the tables and any user views. Right. We may need to do data conversion and loading. Right. Data conversion, again, that was my second job in industry, was about taking existing data into a new database. This is not, I would say very rarely is this a quick process. In fact, what we did for our company is basically we developed the user interface and database for a multi-million-dollar company, was one of our clients, and they had multiple sites that needed to be switched over to our program, and because all of their sites, all of their individual sites, were using different ways of maintaining inventory and maintaining equipment and stuff like that. And like I said earlier, some of those were in Excel spreadsheets, some of those were in Microsoft Access database, some of them used Oracle databases, not many, right? But what we needed to do is we needed to take their existing data and have it be able to come into our system in a way that our system could understand it. And as you start designing your databases, you'll understand why this is can be difficult, right? And so what we would do is we would take a snapshot of their data as it existed, their database as it existed, and for the next, usually somewhere around 3 months, our job was to write scripts that would collect their existing data and format it and transfer it into a form that our database could understand. All right, and transfer it into database tables in our format. Okay, it's a long time, 3 months, but that's because we wanted to make sure to get all of their data, because the problem is things like, for example, let's say they had an item called this, and they had an item called right. Likely those are the same thing, right? Likely that there's a typo there, right? But we needed to make sure that our script treated those as the same thing, possibly, right? Or let me think. I won't think of another example, but right, but those are the types of things that we needed to be looking for, and our script need to be able to automatically handle that, so that when we pressed the convert data button, it all came over. Okay. All right. So we would spend months writing these scripts to convert their data. Right. Then, once those 3 months were up, or we would say, okay, we're ready. We've got all the data ready to go. Right. We've got all the data scripts ready to go to convert the data. So then, usually on a Friday, they would shut down their site. Right. They would shut down their site, give us the new data, because in 3 months' time, data changes, right? Data gets added, right? And then for those next 3 days, we would make sure that our script could now handle all of the new data as well, right? Sometimes it didn't, sometimes it required modifying the scripts a little bit, right? But then at the end of those 3 days, all of their data would have been processed and converted over, and then all of their employees would come back on Monday. They would open up their new system that was our system for them, and they would continue to do their job. Now, during those 3 days would be also training the users on the new system. Okay, so the company didn't waste any time with their, actually said we didn't do it over the weekends. I guess we did do it during the week. Anyway, now, why didn't they just give us why didn't they just shut it down back 3 months prior? I mean, what happens if during the course of what happens if it only took me like a month to write the scripts initially? Why didn't they just shut the company down for the site down for a month and let me write the scripts without having to do that whole thing, like the 3 days thing later? Well, it costs money, right? It costs money to shut down a site. And so, again, it's not always necessarily a fast process, and it's not always an easy process either, right? Being able to write scripts to be able to convert data from a CSV into an Oracle database. All right. Okay. All right. So that's one of the things that we will have to do possibly as part of a new system we're developing. So the other thing I love to talk about is testing. All right. One of the things that I would say is a misunderstanding of the purpose of testing is a lot of programmers usually think that the purpose of testing is to prove that a system works. This is not possible. We cannot prove that a system works. All right. Now you probably maybe, as I say that, think, what? That makes no sense. Why would you? Why do testing if we can't prove that a system works? No. The purpose of testing is to find places where the system is not working. Okay. The purpose of testing in health, for example. Okay, so we just got kind of out of a pandemic. Are we out of it? I don't know. All right. Why did we test people for if they had COVID? Right. Did we test people to prove that they were healthy? No, right? The purpose of testing for COVID was to find places and find people who had the virus, right? Who were infected with the virus. The purpose of testing, running tests as part of a physical, as you get older, you should start having more, none of you know this, maybe William does, but right, you should start having regular meetings with your doctor to find out, what's going on. They're not testing to prove that you're healthy. They're testing to find places where you're not so we can fix it. Right? And the same is true in software systems. We are not testing to show that there are no faults. We are testing to show where the faults are. Okay? And the later we find the faults, the worse it is. The later we find the faults, the more costly it is. So if we can find faults, if we can find errors in the requirements or design phase, that's best. That's great, right? If we find it during the application development phase, okay, can be more costly. The worst place to find errors is for our users to find them, right? If you've ever been working or you've ever been doing something on a computer and you got a pop-up message, a message saying, hey, we're about to shut your computer down in 60 seconds to install this update. Chances are there was something related to an error that a user found before that system went out, was built and went out, that now they have fixed it and they're issuing an update for it. Okay. Again, we can only say that the system works to the best of our knowledge. We cannot say that it absolutely, certainly, without a doubt, works. All right. Okay. So I have a lot of stories about testing, right? But we're running out of time. All right. Right. We should evaluate against the how it should be used. Right. But we need to be cautious about doing what's called the golden path test. Right. Only the golden path test is where we know what the test, we know how the software should work. We know the general way that it should work and how it should be used. And so we only test that. Oh, 2 + 2, output 4. Yay, it works. Right. But what if we then test with something else? 3.3 plus 4.6 and the output is 7. Wait, no, that's not right. All right. And I put this out there because I feel like this is one of those things that are hopefully that you guys understand is as a second year and later students, is that oftentimes it worked on my computer as a reason that we are given as for why the student doesn't understand why they maybe received a certain score on a programming assignment. And it's because we test it for more than just the example, right? And so we need to make sure that you're not just testing the golden path. Yeah, you're right, because they find they find the worst case scenario. So yeah, maybe. All right, so I'll tell a story real quick. So, and let's see. I'll tell a story and we'll end here, okay? Let's do that. And I'm going to use the share thing over here again. So, all right. Okay, so I'm gonna do another one of these here. Okay, and then we'll end there. Okay, so my first job was as a tester. One of the things that it was an ASP.NET application, web-based. So, and one of the things that it did was it searched for documents, right? So there was a search feature as part of our product, and one of the things it created and maintained the documents, but then we could search them as well. And one of the things, you could search by date, you could search by author, you could search all kinds of different things. One of the things we could search for was based on dollar amount, right? So you could have a minimum and a maximum, right? And there were two text fields here, right? Right, with a little dash between them, right? And a little dollar sign off. Okay, so this was what the application looked like, and what it expected you to do is if your minimum could be like 1,000, your maximum could be like 2,000, right? Something like that, right? And during my testing, right, I said, well, what if I put a special character in here? Right, or characters in here. And it gave me this big Oracle error message page with like, it was yellow banner and red text, and it crashed the system. All right. I'm like, well, that's weird. So then I tried putting like a dollar sign in here with 1000 or something like that. And it did the same thing. It crashed the system and gave me this big ugly Oracle error. I might post a screenshot of it later if I can remember. A screenshot of a similar error. So, being the good tester that I was, I put this into our bug tracking software, all right, and put it out to, we'll just make up a name, Steve. Okay, so it was assigned to Steve the programmer. Okay, well, I'm working, and a few minutes later, I hear this person walk up behind me, and Steve says, "I can't reproduce your error. Show me what you're doing wrong." Okay. So I showed him. I typed it in like that. I typed it in like this. And he says, "Oh, well, there's your problem. You're typing in the dollar sign." I'm like, right? He's like, "You're testing it wrong." I said, "Well, what do you mean I'm testing it wrong?" He said, "Well, the dollar sign is here. A user won't type a dollar sign in there too." Users don't always do the things we expect them to do. All right, we need to be on guard against these non-standard ways of using our product. All right, because the truth is, it is possible that a user could copy the amount from some other source, from a website, from another document, and paste it in there and not notice that they copied the dollar sign, or maybe not notice that they copied a special character. All right, and it's not a problem to require them that this field has to be a numeric type. The problem is that when this was entered and the big ugly Oracle error was what they saw and the system was crashed, there was not a what's the word? There wasn't a natural flow way of them to get told, "Hey, this is a bad data. value that you entered, you need to put in a numeric type, right? So we need to be able to have the system exit gracefully. We need to be able to have the system exit gracefully, or give them a graceful error message that they can understand and fix the problem, right? So yeah, so be really careful about only testing for those things that seem to be most likely to be used. All right. Oh, and there we go. We are out of time now. It is 12:20. Are there any final comments or questions? Let me take a look at. Was there anything in the slides that we didn't cover that I wanted to? Nah. Yeah, the rest of the slides, you can look at them on your own, but really I've covered the things that I wanted to cover for today. So is there any other comments or questions before we end? Okay. Thank you guys. Have a good afternoon. Yeah, be on guard for extra characters, special characters. Absolutely. All right. Have a good afternoon. I'll see you guys next week.